Today we're doing coordinate geometry. We've done a little bit of this before. I just like hinted at it in the first semester with during our triangles class, but I never really talked about it. And it actually happens quite a bit in the Mathcounts competition, but the amount of coordinate geometry you have to know for those problems is pretty light. But here I'm going to go a little more in depth with that. So the topics are, we're going to find a formula for the distance between 2 points. We're going to learn how to graph lines. We're going to talk about this really cool formula, distance point to line. They do not teach you in middle school. They do not teach you anywhere. Some high schools do teach it. The high school I go to, it does. I think it's mostly my teacher teaches it. And so this is a formula that not a lot of people know, but it's very, very useful. Finally, I'm going to go over circles. Okay, back to circles. The distance between 2 points, if we have 2 points with coordinates x1, y1, this is 1 point, and the other point is x2, y2, the distance follows this formula. This is called the distance formula. And this is basically just the Pythagorean theorem, right? If we have, let's just say x1, y1 is here, and like x2, y2 is here. Distance x1 minus x2, that's just this distance right here. Since we're squaring it, the signs don't matter, right? Since we're squaring it, everything turns into a positive. So y1 minus y2, that's this distance. And this is a right triangle, so the actual distance between the 2 points is going to be just the Pythagorean theorem. You take, you square these two distances, and you take the square root of that to get the hypotenuse. Okay, so I think most of you should know this already. It's pretty simple. It looks pretty complicated, but generally what it actually means is the Pythagorean theorem. Okay, here are some problems. So these problems don't specify what you should round to. So always give your answer in the most accurate form possible if it doesn't tell you how it wants the answer to be specified. Okay, so these shouldn't take that long. I'll give you guys 3 minutes. All right. The first one, by the distance formula, we've got 0 minus 5, we square that. 3 minus 8, we square that. And we take the square root. Okay. 0 minus negative 5. That's basically 0 plus 5. Let's look at that. And then we can see that this is negative 5. So we got 25 plus 25. Square root 50. And if you take 25 out of that, then you've got 5 root 2. That's how you would get it if you just use the distance formula directly. A lot of the time, it's always better to draw a diagram. 3 up. Then we got negative 5, 8. Something like here. So we know that this is 5. We know that this is 5. So we've got an isosceles right triangle. We don't even need to use the distance formula. We can find that immediately. Okay, so distance formula is just the Pythagorean theorem. It is, I don't think it's something you have to memorize. So just look at the diagram, make a right triangle, and that's basically the distance formula. The second problem, we got to take some knowledge we got from last semester. The centroid of this triangle. What's the distance of the centroid of this triangle from the vertex C? How do we find the centroid again? So we take the average of the x coordinates, the average of the y coordinates, and those are the x and y coordinates of the centroid. So the centroid has coordinates 0 plus 4 plus 8 over 3. And the y coordinate is 3 plus 0 minus 9 over 3. So this is the coordinates of the centroid. It's the average of all the points, because the centroid is the exact middle. If you would define what the middle of a triangle is, it would be the centroid. Like if you marked the centroid on a paper triangle and you balance it on a pencil tip, it will balance there because that's the center. So that's how you would find the centroid. And this would simplify to 4, negative 2. So this is the centroid. This is vertex C. The distance between the x coordinates is 8 minus 4, which is 4. 4, and I'll square that in my distance formula. And I add that distance between negative 9 and 2, negative 2, that's 7. Okay, so this is the distance. And if you add those together, it should be square root 77. Okay, so this is the part about finding the centroid from the coordinates. That's the only time I referenced coordinates in last semester. So if you don't remember that, look at your geometry summary sheet that I sent like five weeks ago. And all the formulas are there, and this one is also in there. This one is a pretty interesting problem. So let me actually explain what this looks like a lot of words. So let S be the set of points that are distance of R away from the point A, B. Find an equation to represent all the points in S in terms of coordinates X and Y. So what this means is that we have a set of points S. S is a letter we commonly use to define a set. So we got a set of points, and they're all a distance of R, which is a constant distance away from this point. So let's say this point is right here in space. And all the points in S are a distance of R away. If you graph all those points, it's going to make a shape. And you're going to have to find the equation of that shape. Okay? So that's what it means. And that equation has to be in terms of X and Y, A, B, and R. Okay? And this should not take long, actually. I'll give you guys 3 minutes. Right, so for this problem, what we just have to do is the distance formula. Let's say one of the points that are in S, let's say this is x, y. All right. Well, then xy is the distance of r away from AB, right? What this means is that we can use the distance formula. Yep, I see Chloe got it. Yep. So if right, if the point we want is xy, generally all the points are going to be defined by these coordinates x and y. It must be a distance of r away from AB. By the distance formula, you got r must equal x minus a squared plus y minus b squared. Okay, you could have done it a minus x squared, b minus y squared to give the same result, because when you square everything turns into a positive number anyways. Okay, so this is actually the formula you can use to represent all points in S. If you actually square both sides, you can get rid of the square root. It actually looks a little bit better if you square both sides. R squared equals x minus a squared plus y minus b squared. So if you think about it, what are all the points? What does this even look like if I were to graph this? Well, if we have a distance of r away, let's say this point is here, one of our points, okay, distance r. We can find all the other points by like rotating this line across this pivot here, because that gives us all the points that are distance of r away. We rotate that around a pivot. Oh, look, it's a circle. And I think that's pretty cool. This is actually giving you the equation of a circle. And that's what we're going to look back at later on in today's class. So if you've found this equation by yourself, this is actually the equation of a circle, and that's how you derive it, distance formula. Now I've got how we should graph lines. There are three ways to graph lines. The first way is slope-intercept form. I think you all should be pretty familiar with these ways to graph lines. M is the slope. We always use the letter M to define slope. If you don't know what slope is just how steep the line is. Okay. If the line is steeper, it's got a bigger slope. If the line is skewing to the left, like this, that's a negative slope. If it's skewing this way, it's got a positive slope. And how you find slope is you take any 2 points, x1, y1, and x2, y2 on the line, and the slope would just be y2 minus y1 over x2 minus x1. Or you can do x1 minus, y1 minus y2 over x1 minus x2. These both work. You can just choose whichever one you want, because there shouldn't be an order to which one you define as y2 and y1. Okay, so that's how you find slope. B is the intercept, the y-intercept here. Okay, that's the point where the line cuts the y-axis. So that's point slope-intercept. This is the one that's pretty useful, actually. Point-slope form. This is the equation of a line if we have a point and a slope, any point. Any point on the line with the coordinates x0, y0. This is the coordinates of a point on the line. And y and x here are just the variables. Okay, so if we had the point, let's say 1, 1, then these would be x0 and y0. Then our equation, let's say the slope is like 2, then we've got y minus y0, which is 1, equals 2 times x minus x0, which is 1. And this is our equation of the line. See, y and x are still variables because they define the line. Okay. So whenever you have a point and a slope, you use point-slope form. And finally, you got standard form. This is the least useful in terms of graphing. This is just, if you take all the terms and you put them on the left side and you got a 0 on the other side, that's standard form. We're going to look back at that later. So basically, when you're graphing lines, you're only going to use these two, not this one. This one is pretty bad if you're graphing lines. Right? Well, hopefully this should be like more like a review for you guys, because you are doing math counts, you are advanced math students. So without doing any problems, we're going to go over to perpendicular and parallel lines. So let's say we have a line A with slope m. The slope of this line is m. This is A, and the slope is M. If we have another line called line B, and it's parallel to line A, line B has the same slope, which is M. They're parallel, same slope. And that makes sense because they gotta have the same steepness. Otherwise, they would crash into each other sometime, and then they wouldn't be parallel. If line A is perpendicular, the slope is -1 over M. So line B is actually perpendicular to line A, like this. Well, obviously, if A was positive slope, like this, B would have to have negative slope. That logically makes sense. But you have to take the negative reciprocal, -1 over M. So the slope of A was 2. The slope of B is -1/2. Okay? So if the lines are perpendicular, the slopes are the negative reciprocal of each other. And reciprocal basically means we're taking 1 over M. Okay, so that's the relationship between the slopes of perpendicular and parallel lines. Okay, so now we've got 2 problems here. Give you guys, second one is from a Mathcounts competition. So I'll give you guys 5 minutes. All right. First problem, the line given by this is perpendicular to line A. What's the slope of line A? So first, got to find the slope of this line, right? To find that, we got to get this in a point slope form. And as you can see, this is still not point slope form, slope intercept form. As you can see, this is in standard form, which is pretty useless to us. So we got to get this into slope intercept form, which means we get the y to the other side, 3x plus 9 equals 5y. Divide by 5 on both sides. This turns into 3x over 5, 9 over 5 equals y. This is the slope of this line. And if line A is perpendicular, you gotta take the negative reciprocal, which is negative 5/3. Okay, that's the answer. Next one is from Mathcounts, 2019 chapter sprint round. Okay, I remember doing this one myself when I was in 8th grade. So the line is a tangent to the circle at 0.25. Parallel line is tangent at 813. What's the common slope? So it's always good to draw out a diagram. So 2, 5. So this is point A and this is point B. Okay, point A, point B, somewhere here. And they're both tangent to a circle. Like that. What is the slope of these two parallel lines? And they're parallel. Okay. Well, based on the definition of a tangent is perpendicular to a radius drawn from the center to that point. Since they're perpendicular like this, I've drawn a diameter here. They're both perpendicular to this diameter line. And the diameter line has slope that is given by these 2 points. The slope of this line, AB, well, we can just use the definition of slope. That's 13 minus 5 over 8 minus 2. 8 over 6, 4 over 3. So 4 over 3 is the slope of this perpendicular line to the two parallel lines that we want to find. So to find that, we just take the negative reciprocal, which is negative 3/4. And this is the answer. Okay, and if you look at the diagram, it does make sense. These are negative, and they kind of look like they have a slope of 3/4. Okay, so here you got to use your knowledge of circles as well, alongside your coordinates. Okay. Now I got a nice formula that no one ever talks about. Distance point to line formula. Let's say we had a line in space that's determined by this equation. Okay, which is in standard form. This is the only case where you're ever going to use standard form. Standard form for a line. Once we have a line in standard form, let's just say this looks like that for some reason, I don't know. Some other point, x0, y0. When we say what's the distance between this point and the line, we talk about the shortest distance. So like makes it perpendicular. We're not talking about this distance, not talking about whatever that distance. Whenever we say what's the distance between a point and a line, we say what's the shortest distance between them. And that's what we're referring to right here. And that distance is determined by this formula. We take the standard form. We do the coefficient of the x coordinate times the actual x coordinate of our point, coefficient of the y coordinate times the actual y coordinate of our point. We add that last constant in there. And we take the square root, take that all over the square root of a squared plus b squared. Remember to take the absolute value here. This means absolute value. So if it's a negative number, you have to turn it to a positive. Because distances are not negative, right? You can't have a negative distance. So that's why we had to take the absolute value there. Okay. I'll give you a moment to write this down in your notebook, or somewhere where you're taking the notes. This is a very handy formula. Very handy. And it's got to be in standard form. And A has to correspond to the x coefficient. B is the y coefficient. And C is the constant. It has to be that way. All right. We're all good. I will move on to the next slide. We'll use this formula. I'll give you guys 5 minutes. Okay, so the first problem what we have is a point in a line. So to use the distance point to line formula, you gotta turn this into standard form. Everything has to be on one side with a 0 on the other side. So let's do this here. Now it's in standard form. We can find the distance with the formula. Distance is equal, well, the coefficient on the x is 1, coefficient on the y is 1. We do 1 times x0, which is 1. 1 times 1. We add the constant, which is 0. There's no constant. Absolute value over square root 1 squared, which is this, times square root 1 plus square root 1 squared. And now you get 2 over square root 2. Square root 2. Another way you could have found this answer was just graphing it, right? If you graph it, 1, 1 is here. This line y equals negative x, that's perpendicular to the line y equals x, right? And 1, 1 and 0, 0, 0 are on that line. So they're perpendicular, which means that we just need to find this perpendicular distance right here. We got 1 up, 1, 1 right. So this is just square root 2 by the isosceles right triangle we have. Okay, so that's the way you could have found it. The next line is a bit more complex, which is why actually the distance point and line formula would be much better here. So let's get in standard form first. So move the 4y this way. You could have moved the 3x minus 5 that way, but that would be a little more work, like moving 2 terms to the other side. Any way works. I'm going to move the 4y. 3x minus 4y minus 5 equals 0. So now we've got 3, negative 4, negative 5, which means now we just use our distance formula. 3 times x0, which is 1, minus 4 times y0, which is 1, minus the constant. Absolute value of that over 3 squared plus negative 4 squared. The top turns into negative 6. Absolute value of that, we got 6. The bottom turns into 5. So this is actually the distance. 6/5. All right. I'll skip the second one because we're running a little on time. I want to get the circles. So I'll leave that in the homework for you guys to do. Okay. Back to circles. So if we have a circle with center at point AB and radius r, the equation of the circle is this. If you go back to the beginning of class, we actually derived this formula with the distance formula, and that's basically what it is, right? A circle is just the set of points that are a set distance away from another point, right? If we have AB here, a circle is defined as all the points that are distance r away, which means we spin this line around itself to make a circle. And all of these points are distance r away. And that's a circle. So this is the formula for the equation of a circle. It has to be in this form, x minus a, y minus b, because you're subtracting because that comes from the distance formula. Okay. For example, if we had x plus 1 squared plus y squared equals 9, the center is negative 1, because if we subtract negative 1, we get positive 1. So a here is actually negative 1. So the center is negative 1. There's no b. The b is not even there. So the y coordinate of the center is 0. And the radius is the square root of 9, which is 3. That's how you use this formula. Equation, actually. It's just like a line. This is how you would graph a circle. Any questions? Very cool. Now we've got this first problem should be pretty straightforward. You just need to, this should be a plus here, sorry. That would not make a circle. Should be a plus. So if you've done the first problem, the second problem requires you to complete the square. So if you've been to Algebra 1, you know how to complete the square with a quadratic. So yeah, so you have to complete the square to find the equation for that. Because the only way you can find the equation of a circle is if it's in this form. Okay, and this is not in that form. You got to get it into that form. So complete the square for the second one to get it into this standard form, we call it. So we can find the center of radius. All right, I'm running a little low on time, so I'll quickly go over the second part. So how you complete the square is you got to turn these into perfect squares. Okay. And to do that, we add 4 here. We add 25 here. You got to do that to the same thing on the other side. As you see, x squared minus 4x plus 4, that is x minus 2 squared. So we add the right number so we can make it a perfect square. So right here, this is y plus 5 squared. On this side, negative 2 plus 4 plus 25, that's 27. So the center is 2, negative 5. And the radius is square root 27, which is 3 root 3. Okay. If you've done algebra 1, that should be an extension of completing the square. You would normally complete the square to find the shape of a parabola. But you also use it for circles. Okay. So another thing you need to know about circles is a review from last semester that if we have points A, B, and C on the circle, the center O is the intersection of all the perpendicular bisectors of adjacent points on the circle. What this means is that let's say I have 3 points in space. Remember a triangle? Remember when we talked about triangles, if we have the circumscribed circle, the center of the circle is the intersection of all the perpendicular bisectors of the sides. Center's right here. So if we have like a certain number of points in space, let's say this was like 1, 1, this was 2, 5, this was 0, 7. Then we can find the center of the circle by finding the equation of this perpendicular bisector here, finding the equation of this perpendicular bisector here, and then using those two equations to set them equal to each other to find an intersection point. Okay, so that's how you would find the circle given by these 3 points. Okay, so that's a review from last semester. So let me skip that. Let's do this problem. It's actually a 2-part problem, actually, not 2 separate problems. Let me actually show you how to do this, and then you'll be able to do it on the homework later. Okay, because we're running a little on time. So we have this triangle. What is the circumradius of triangle ABC? Well, to do that, we can find the equation of the circle that works for triangle ABC. And then that'll give us the radius, right? So let's actually graph these points real quick. 1, 4, 3, 2, somewhere like here, and 1, 2. These are the 3 points. If we draw a circle to connect these 3 kind of look like that. So we got to find what's the circumradius, which basically means we can just find the equation of the circle, and then that will give us the circumradius. So first we got to find the equations of the perpendicular bisectors. Any 2 will work. There are 3 you can find. Any 2 will work. So I will find the perpendicular bisector of this side, perpendicular bisector of this side, and their intersection point has to be the center of the circle. So what's the perpendicular bisector of these 2 points? Well, it's perpendicular and it bisects the 2 points, which means it goes straight through the midpoint. So this is actually between C and B. So C is here, B is here, C is here, and A is here. Okay. So if it's a perpendicular and it's bisecting, it goes through the midpoint, and its slope is perpendicular to the slope of CB. So here we're actually going to use point slope form to find this equation. So what's the point? Well, it goes through this midpoint here, and the midpoint is given by 2, 0. Not 2, 0, 2, 2. The midpoint is found by averaging these 2 points, the coordinates. So that's the point. And the slope, well, the slope of CB is 0, which means the slope of this line is undefined, which basically means that this is an equation in the form x equals k. X equals something, okay? And k is actually equal to 2 because the x coordinate of this point is 2, which means all the points on this line have to have an x coordinate of 2. So the first perpendicular bisector right here has an equation x equals 2. Now let's look at AC, the perpendicular bisector of AC. Look at these 2 now. The midpoint is 1, 3. As you can see, this is one of the equations where we have a y equals k. It's a horizontal line. K is 3 because this point here has a y coordinate of 3. All the points on this line have a y coordinate of 3. So the other line is y equals 3. These are the 2 of the perpendicular bisectors, and which means that the circumcenter, the center of the circle, must be the intersection point of these 2 lines. And that point is going to be the point 2, 3. Okay. After you found this, you can just use the distance formula to find its distance to any of these 3 points, and you'll get the radius. Okay. And once you have the radius, you can then find the equation of the circumcircle. Okay. So let's actually find the radius real quick. It's the distance. I'll just choose this point. Okay. What's the distance of 2, 3 from 1, 4? By the distance formula, we got 1 squared plus 1 squared, square root. This is the distance, which basically means this is the radius. So the equation of the circle is going to be x minus 2 squared plus y minus 3 squared equals square root 2 squared. All right, because I have to use the center here, 2, 3, and those points go here. And the radius is squared right here, which means I can just simplify that, get rid of that. That's how you would do that problem. Okay, I've gone way over time. Sorry about that. But hopefully, if there are any questions, let me know. But that will be the end of class today. All right. So I'll see you next week then. Okay, if you have any questions, I know that was a little rushed at the end. Any questions, just turn on your mic and tell me. Okay.